Just over 100 days ago, a deadly virus took an unprepared world by storm.
COVID-19 can be characterized as a pandemic.
But as the world scrambled to react to this growing emergency, an astonishing global scientific effort began to understand the nature of this new enemy and how we could fight it.
第三次世界大战，我们的敌人是看不见的病毒。
The WHO is saying that there are no proven effective therapeutics to be had for the new coronavirus.
Efforts are focused on detection and containment.
A vaccine is still at least 12 to 18 months away.
As the coronavirus pandemic escalates, knowing we have such a long wait until we can immunize can be pretty scary.
不容坐以待毙的恐惧蔓延，全球迎来了一场医疗科技的军备竞赛。英国强调，克敌制胜得追本溯源，率先由剑桥大学基因遗传学教授 Peter Foster 透过2019年12月24日至2020年3月4日，采样自全世界各地的160个病毒基因组数据，绘制出新冠病毒的原始传播图。
I didn't, in fact, start my research in Wuhan.
I thought it was the A section.
My research started when I realized in early February that the outbreak was a serious matter, not simply like a flu. Is that the earliest genome which has been placed into the database is not necessarily the origin of the disease. If I had sampled, someone from Scotland and put him in the database first, then obviously it would look as if Scotland was the origin. That is not a valid approach.
当时全球正在争论新冠病毒的来源是中国还是美国。这份被国际知名期刊《美国国家科学院院刊》认可的研究，将不断发展突变的新冠病毒分为 A、B、C 3类。A 型最接近蝙蝠身上发现的冠状病毒，也就是原始病毒。虽然也曾在武汉出现，却不是武汉的主要病毒类型。反倒在北半球的美国、西班牙及南半球的智利和澳大利亚遍布它们的踪影。而由 A 变异产生的 B 型病毒是武汉流行的主要病毒，但它不仅在武汉流行，还传播到中国其他地方及整个东亚。欧洲的英国、比利时、法德、芬兰、丹麦，北美的加拿大和南美的巴西。至于在欧洲流行的 C 型病毒，看似是由 B 型病毒变异而来，却广泛存在于意大利、香港、新加坡及韩国病例中，遍寻中国大陆的样本完全没有。而这样的病毒分类也有助于模拟病毒演化，进而推算出突变率。这也意外找出了新冠病毒真正爆发的时间点。
We find that the first infection, possibly from a bat to a human, happened no earlier than the 13th of September 2019 and no later than the 7th of December 2019.
新冠病毒对人类来说，无疑是一个全新的考验。不同于先前冠状病毒家族的 SARS、MERS， 新冠病毒传播力极强，致死率也高。《华尔街日报》日前整理近期全球医界发表关于新冠肺炎的论文，就发现，有别于冠状病毒向来锁定呼吸道和心肺攻击 ，COVID-19 在相当大比例的病患中，影响的是他们的大脑及神经系统。症状包括脑炎、幻觉、癫痫、认知缺陷及气味觉丧失。
Generally, the blood-brain barrier does a good job of keeping these viruses out of your brain. You can think of the blood-brain barrier as a fortified wall protecting the brain. It's extra selective about what it allows access to the central nervous system. Although it's good at its job, unfortunately, it's not impenetrable to all unwelcome visitors. Sometimes respiratory coronaviruses are able to jump the blood blood-brain barrier and gain access to nerve cells in the brain. Remember how I said viruses can hijack your cells? COVID-19 does this by interacting with a cell receptor called ACE2, angiotensin-converting enzyme 2 receptors. Generally, these receptors are highly expressed in the lungs, which is why the lungs can become severely affected by COVID-19. But ACE2 receptors are also found in many other tissues, including the heart, the kidneys, intestines, and testicles, for example. In fact, these receptors also seem to be widespread throughout the brain, with particular focus where neurons are involved with heart and lung function.
事实上 ，COVID-19 对大脑及神经系统的冲击，早在武汉爆发疫情时，便从其中2家医院获得证实。实验室采样的214个确诊病例中，有78个都出现相关症状，甚至肺部及呼吸道症状较轻微的患者，神经相关疾病，包括头晕、头痛的状况越严重。
This understanding is based off the study of similar coronaviruses like SARS and MERS. SARS and MERS were believed to enter the brain via the olfactory nerves, the nerves that you use to smell, where they continue to infect specific brain areas, including the brainstem, an area known for respiratory control, or the control of your breathing. Although this sounds quite ominous, it's important to point out that significant cerebral involvement is one complication of many in COVID-19 patients.
更让人忧心的是，近期大陆及美国研究单位不约而同发现，新冠病毒越来越像艾滋病，会攻击人类的免疫系统。在20名死于新冠肺炎逝者的解剖报告中，初步发现死者的免疫系统都几近全毁。换言之，病毒攻击的并非个别器官，而是让人体全面性的产生免疫风暴。这也使得老药新用成为医界当下和时间赛跑的救命捷径。市场对此抱持高度期待。16号道琼盘后大涨，正源自吉利德药厂对抗病毒药物瑞德西韦适用性的乐观。因为有消息指出 ，FDA 最快5月中就会有限度地通过该药临床使用。
Using pre-approved drugs is the best strategy in the short term to help people as others develop maybe more sophisticated targeted approaches, say with a vaccine or with drugs that target the virus, but that could take months, if not years.
华尔街日报报道称，一个由美国政府机构和科技公司所联合组成的联盟，正透过超级计算机帮助研究人员加速研发新冠抗病毒药物。他们所根据的是麻省理工学院所开发出的一种蛋白质疗法。因为病毒是透过与人体的 ACE2 受体结合而致病，医界于是制造一个诱饵，让病毒与假蛋白结合，从而预防及治疗疾病。另一个国际组织也是运用相同机制，但锁定的是开发中的药物。负责的 Nevin Cregan 教授透过病毒感染机制，详细描绘出会遭到劫持的蛋白质蓝图。交相比对后，找出了当下全球共计有69种药物，足以抑制这332种人类蛋白质，而其中27种药物已获得美国 FDA 核准，剩下的也正在进行临床试验。
The logic here is if we do get a hit on one of these drugs, we can go and look at one of these drugs in more detail and then see what other drugs or compounds are similar to it. So we can expand our search space based on this initial screen at the end of the day, which will give us hopefully a higher likelihood of success.
同一时间，世卫组织宣布，全球正在研发的70种对抗 COVID-19 疫苗，已有3种正式进入人体试验阶段。目前在临床上拔得头筹的是香港上市的一家生技公司及北京生物技术研究所开发的一支实验性疫苗，另外2种则分别来自美国2家制药厂。为了加快新冠肺炎疫苗的研发速度，全球2大药厂格兰素史克和赛诺菲也宣布史无前例的合作。新疫苗将采赛诺菲的疫苗搭配格兰素史克开发的佐剂，提升效力。如果一切顺利，最快2021下半年可以投入市场。
There's a lot of good news here. Biotech companies are working with governments and regulatory agencies and academia all around the world to get this vaccine done, to get therapeutics invented. The FDA, for example, in the U.S. is working 24 hours a day, 7 days a week, really around the clock, making sure that experimental medicines are getting through the system, that existing medicines are getting what's called emergency use exemption, so that doctors have the tools they need to fight for those people who are the most ill. But my guess relative to a vaccine is probably 10 months to a year. And for vaccines, that's pretty fast. So I think there's pretty solid cause for optimism.
不少人乐观预期，这场全球生技竞赛将让疫苗上市时间缩短到1年内。但美防疫专家佛奇态度依旧保留，认为最终核准上市时间不会离12到18个月太远。因为当下固然是人类该携手团结的时刻，但因诡谲多变的新冠病毒，研发机构在试验阶段仍应随时更新病毒变异的状况。毕竟这场体力、人命与资源的消耗战，安全是唯一标杆。